Alright, hello everyone, welcome back to another MathYourDay channel. So in today's channel we'll be looking at the linear functions, right? So the standard equation of the linear function is given as y is equal to ax plus q, where y of course is an independent variable, right? A is the gradient of the gradient of the function, x is a dependent, and then q is the y-intercept, right? So when dealing with function, they can ask 5 different um, things, right? They can either ask you the domain, the range of the function, sketch the function, finding the missing variable, in this case maybe finding the gradient, or q, right? Also written as c, right? Finding the missing variables, looking at the perpendicular and parallel variable gradient, and then of course the inclination, right? So in today's video we'll be looking at how to sketch um, the linear equation, right, and finding the domain and range, and of course if we have time looking um, at how to find different variables. So basically here if we have, for instance, 2x minus y is equal to 2, so here you have to manipulate the equation using algebraic expressions, right? So meaning you have to um, transpose the 2 that side and then transpose the y that side, so that you make y the subject of the formula. So meaning we have y is equal to, transposing the y that side will be positive, and then the 2x stays as positive, and then if you transpose the 2 on the side it will be negative 2. So this is what we call manipulation of a formula, right? You are most likely to encounter this in your exams. Of course you have to just work a little bit of algebra to make the y the subject of the formula. So if you look at what is a domain, right, let's first understand what the domain means. So domain are x values. First of all, they're x values. So if you think about it, what do we mean x values? So by looking at domain, if for instance we have a function here, these two arrows here, they say something. They mean infinity, right? Positive infinity and negative infinity, meaning that the the function does not stop, it goes on to infinity, right? And of course here means that the function comes from negative to positive infinity, right? So that's what domain is, but we're looking at x values in that case, right? So we're looking at x values that satisfy the graph, right? So in this case we notice that all these x values, they all satisfy the graph. Why? Because if I have negative, for instance, a million, or negative 10 times whatever value that you can put there, right, it will be on the graph, right? It will give you a number, right? It will give you a number, so meaning it does satisfy the graph. So that is what we mean by domain, right? Values that satisfy x values that satisfy the function in that case, right? And then the range is basically the y values that satisfy the graph, right? So in this case, if I have a function, right, say this is negative 2, yeah, let's say this is negative 2, and then I ask what is the domain of this function. So we notice that here we do not have the error that indicate that, okay, this is a continuous function. Instead we have the graph ends here, right? So meaning that our domain will be x element of or rather x element of 2 to positive infinity. Notice how I use these parentheses. So this means that we are including the 2 in our function. Then of course here I'm using these brackets. Why? Because we do not know what the value of infinity is, right? We do not know, so meaning we use this bracket here. But if we know, in this case we know that the function starts at -2, so we can use this parentheses here, right? We can use the parentheses. So make sure that you understand what the term domain is, right? Because they can give you a function like this, and then maybe a -3, then they say find the domain. But because you are used to saying x is an element of real numbers, this is wrong here. Why? Because we do not have the error here. Instead, the function, it ends here at this point, right? So meaning x, in this case, an element of -3 to infinity, right? So this is the domain of this function here. Then the domain of this function here will be -2 to infinity. So take note of these small things right here. So this can also be this is also known as a restriction, meaning that we are restricting some values, right, of x in that case. So meaning we are restricting all the values that are less than -2 in this case. We are restricting them, right? Hence why we use the parentheses here, and we are including the -2, right? So that is what we call the domain and the range in that case, right? So now let us understand how to sketch these functions, right? Let's understand how to sketch these functions. Okay, let me just remove this. Right. Okay, so let's say we have these functions right here. Okay, so first of all, there's ways of sketching the functions, right? So the first thing that you need to understand is to understand the shape of the function, right? So if a is greater than 0, if a is less than 0, and if a is equal to 0, what is happening to the function? So here we notice that a is greater than 0, so meaning that we are in an increasing function, right? So basically our function is accumulating, so meaning we'll have functions that looks like this. If a is greater than 0, then we have function that looks like this, meaning that our function is increasing. Remember that to identify whether a function is increasing or decreasing, you look from negative values to positive values. So in this case, you can see from negative we are going all the way up, right? And then here you can see that the function will be decreasing. From negative, you can see that it is decreasing, right? So meaning our function will look something like this. Now if a is equal to 0, so meaning in that case, remember that y is equal to ax plus c, or rather q, doesn't matter. So if a is equal to 0, so meaning we are left with a is equal to q, so meaning this here will basically be a line that looks like that. We'll get a function that looks like this, right? Function perpendicular to the x, or rather parallel to the x-axis, and of course perpendicular to the y-axis. So make sure that you understand the shape, right? And then number 2, to find the x-intercept and the y-intercept, right? That's the second thing that you have to understand, and just plot the graph, right? Those are the 2 things that you need. I don't think there's anything else that you need to plot the straight line function. And of course, if for instance we have if our function is given as x over a plus y over b is equal to 1, make sure that this here is a 1, it's a positive 1. So if in that case our function is like this here will be an x-intercept, and this here will be our y-intercept. So for instance, if we have, let's take this function here, let's take this function here, okay. Where's this function, man? Hey. Okay, let's take this function for example, right? So what we notice? We notice that this here, the independent variable is in the same plot with the dependent. So we need um, the independent variable to be on its own, right? On the left or on the right, and then these two be on the same side, right? So what we do is we say gy is equal to 6 minus 2 x, and then you divide by 3, so meaning y will be equal to this will be 2 minus 2 over 3 x, right? So now everything becomes easy. Plotting this, we notice that a is less than 0, right? Because this is a negative here, so meaning our graph will be like this. Then 2 is to find the x-intercept. Notice that the y-intercept is 2, and then the x-intercept, you let y equal to 0, therefore you have 2 equal to 2 3 x, and then this is 6 divided by 3 is 3, meaning x will be 3. So we just plot here x equal to 3, and then y equal to 2, and then it just plot the graph. Now the other way of doing this is to use this formula here, xa plus y over b should be equal to 1. So let us just manipulate this function real quick here. So we have 2x plus 3y is equal to 6, right? So we need a 1 on this side, so meaning can divide here by 6 by 6. So this here will be 1, and this here is 1 over 3 x, and then here will be, this is 2, right? So 2y, right? So now we have to put the x on top. So to do that, what you can do is can put this as x, right, over 1 over 3, ne? For times, no, this is basically x over 3 and plus, yeah, plus y over 2, I'm sorry about that, which is equal to 1. So meaning that we said this is our x-intercept and this is our y-intercept, right? So this is how you can play around with this formula. But the most important thing is to know is sketching the graph, right? What you need to sketch the graph, you need the gradient, rather checking whether the graph is decreasing or increasing, right? And then the second thing is basically your intercept, right? And then of course knowing when to use these errors, right? So for instance, if I said here x element of, let's say, negative 2 to infinity, so meaning I would remove this error here, and then just put a negative 2 right there. So this is how you tackle the linear equations. So that is it for this video. Next time we meet, we will be looking at finding the missing values, perpendicular gradient, and inclination. So thank you for watching. I'll catch you later. Yeah.